right? So the whole idea is actually to search without accents, right? So the question is about, however, the person asking the question is not asking about our capabilities to search for things using whatever comparison in where clause or the like predicate, but would like to actually have a kind of a cache column, if I understand correctly, where the strings are already stored in normalized form without diacritics, without accents, and I guess lowercase probably. So this makes sense for certain type of searches, especially the like search, for performance reasons, right? If you do this using the like predicate and there is no prefix, so you have like % at the beginning of the search pattern and at the end, then we cannot use linguistic index, so you actually have to search and then apply the NLS sort function internally, so the whole linguistic processing for each value, which is kind of expensive. So to speed this up, it may make sense to actually prepare a normalized string, then to normalize the search term, and then to do a fast binary search for a given string. So the question is about having a function that does the normalization. And here the problem is that we don't have such function directly. There is no function which would be called base letter, because basically what we need here is a base letter. This is how we call a letter with accent stripped and normalized to lowercase, for example, or uppercase, doesn't matter what, to one case, right? This would be a base letter for a given accented letter. We don't have such function. We have such functions internally in our libraries. However, they are not externalized through any SQL or SQL or PL/SQL interface. So there is no direct way to do this. This is actually a nice enhancement request. I thought about it for a long time, so it's probably time to look into this and maybe provide such function. We don't have to do too much to get this. For now, the one idea, a bit complicated actually, that I had, of course, for certain limited number of accents, like French or just French, or French plus Spanish, or French plus Spanish plus German, right, where the number of possible accented letters is relatively low, the best thing is just to use the translate function, which allows us to translate any given character to any other given character. This is, however, of course, limited to certain number of characters. So you could solve this issue with a with a bit more complicated way, and I will show this in just in a moment. I just need to share the right screen. Okay, so we have here a database, right, which is WE8 ISO 8859P1. Doesn't actually matter much, right? And the whole idea is that we take a string with accented letters and try to remove accents out of it going through Unicode operations that we have, right? Because this is not a Unicode database, we cannot do the decomposition function directly, because the decomposition functions works in Unicode only, on Unicode character sets only. Therefore, unless the database is AL32 UTF-8, in which case we can simplify the whole idea of it, we have to actually take the string, convert it to our national character set, which is either AL16, UTF-16, or UTF-8. So it is a Unicode character set, right? And once it is already in Unicode, we can apply the decompose function. For example, actually not the, for example, but actually the canonical version of it. You could actually use compatibility as well, which would probably normalize a bit more. But this is something that needs to be investigated. What is the more expected way to search strings? Whether we just want accent stripped, or we want some certain compatibility letters to be considered equal as well, right? Uppercase 1 with lowercase 1. Once we decompose, the decompose function will take each accented letter and will produce a string that contains the base letter in Unicode, right? And the accent in the form of combining diacritical mark. There is a certain set of such characters in Unicode. These are characters that don't have any meaning by itself, but they get combined. So it's why they are called combining. They are combined with the preceding letter, which is the base letter, to produce an accented letter. You can have actually more accents, more than one accent, following the base letter. So the base letter can have more than one accent. And this is used in some languages, for example, in Vietnamese, which is written with Latin script. Then it may have, I think, even at least three accents around one Latin letter, because you have to somehow encode all the particularities of East Asian languages in Latin, which is a European script. So once we have decomposed the function, we can actually remove all this combining diacritical mark out of the string, right? There is quite a number of them. I tried to list all elements of the 3 blocks of combining letters. If we look at the, let me share another screen for the moment. Okay, so there is this combining diacritical marks main block, right? So all the characters in this code range are reserved for the purpose of storing accents. There is another block here, extended. This is very general approach, right? Most of those diacritical marks are not really needed for any text that you want to process, because they are used for pronunciation and for many things. But if you want a full solution that these three blocks is actually one for symbols, but I assume for symbols we won't want to do anything, right? So I have listed hopefully most of those combining marks, at least for Latin. There are combining half marks. So one have to review what's needed, right? And now back to SQL Developer. We have these 3 blocks that I shown a moment ago, right? And we want all these characters to disappear. So classically, we have to prepend X and replace with X, because otherwise we cannot specify an empty string here, because it is treated as null and causes an issue. So the typical way to avoid it with translate is to add some letter that you translate to itself at the beginning, right? So these 2 strings, I use the unistring function to actually be able to encode all the characters using their codes, right? So these are Unicode escapes of all these combining diacritical marks. The unistring function makes an actual national character string text out of it and passes it as an argument to translate. So translate works on the in the national character set now. So we take the original string, decompose it into base letters and accents. Then we strip all accents, and theoretically we could at the end we could also run the compose function, but because we actually want to normalize and hopefully we have removed all accents, we can skip the compose step, especially that we don't really know if the original string needed the composition or not. Probably if it was P1, it was composed, because there are no decomposed characters in this code page. However, in this case, we should not need it. We should convert whatever we have back to the normal database character set, assuming this is what we want, right? And then if we run this query for the string, right, we will see that accents were stripped, right? It does not do full normalization that we might want, for example, because we see that the SZ character, which is not accented, so it's fine, there is no accent to be stripped. However, this letter actually, when it is normalized for search, should be treated as double S, right? However, this method will not do this. For this, we should actually do maybe an uppercase additionally, and then upper, sorry, of course the function is upper, not uppercase. Okay, and this still did not change anything. We would have to actually do an ls upper with the parameter sort equal x. And this is the maximum normalization that we can get. Of course, this is hard coding to German, so this is actually not a best idea, but there's not much that we can do here because of kind of language dependency of this normalization. So we can skip uppercase. We can do normal uppercasing, right? Because when we normalize them, we should actually normalize the case as well, right? However, this letter SZ will not be uppercase linguistically to double S as normally expected, because this is a language specific functionality that you can only get if you use German. Okay, so this is kind of quite complicated way to get to base letters by stripping accents. Whether this is something that one wants to do, or maybe somebody wants to just go with translate, and if this is for Western European languages, right, then what can be done is simply you take the Western European Microsoft code page, right? Okay, this is a character map utility, right? We have here the Western European code page as it looks, right? And we have all accented letters here, so we can just select all these letters from here and do a much simpler translate without the code, without going to national character set. If this is enough, then just use translate, right? For more general solution, when you want to do this for strings in other languages as well, you need to do this more complicated method that I've shown here. As said, if the character set is actually not some legacy single byte, but it's actually AL32 UTF-8, then you can skip this step, and this step can be then skipped, right? If you do this with P1, then as you see, this won't work because the decompose function does not work on in P1 on the varchar2 data type. It does nothing simply, right? It returns the same string, and this is exactly what you get. Just the upper function will uppercase. Okay. I see. Can you try to use ASCII string on top of the compose and then eliminate characters looking regular express? This wouldn't. So let me read the question so that it is on the recording as well. Can't you try to use ASCII str function on top of the compose and then eliminate the /xxxx characters using regx replace, so regular expression replace, supposing the remainder such characters are the accents. So the problem here is that in the more general approach, we may have accented letters over Greek and Cyrillic and some other letters and alphabets, right? In which case, these characters may also end up with this escape sequence, and that we will eliminate them as well, which is not good, right? So the elimination of the accented of the accents that I have shown is better, I think, safer. And the long string that I have shown may be reduced because this one was very generic. I mean, I just took these 3 blocks of accents and removed and listed all the codes from the blocks. And actually, some of those codes are not yet defined, right? So this is more for future. They are not defined. Some are defined, but they are not really expected because some of them are for ancient Greek or some pronunciation in IPA standard. So they will probably never come up with the text that we want to search, which means we can probably review this string that is used for normalization to get some to shorten it and get better performance, less resources used for this purpose. So I hope this answers the question, right? So, I mean, removing just the backslash, the Unicode escapes is risky because ASCII string is not even, I'm not even sure if it is, if it promises what it changes to escape sequences and what it keeps as base letters. I think it just keeps ASCII as base letters. And as I said, there may be other accented letters, not necessarily ASCII, if we talk about more general approach, like non-Latin based accented letters as well.